Hi everybody, this is your last official Monday. Whoop whoop. Okay, how about that? I know everybody's excited. We're going to still be doing statistics, and in statistics we're kind of doing probability, but it's going to be called conditional probability. I'm going to take you back to regular probability, which is over total. This is a deck of cards, and Mr. Emery printed this nice information about a deck of cards for you. So hopefully, if you have a printer, this will be nice to print. You can use it on your quiz on Friday, your last quiz too on Friday. Another whoop whoop. Okay, and then the other sheet printed for notes, but you really don't need to print the other sheet. A nice sheet of paper will do just as well. So for regular probability is what it is over the total. So we got clubs, diamonds, hearts, spades. There's 13 of each suit. So if I said to you, what is the probability of picking a heart out of a deck of cards? Well, since there's 13 hearts, it'd be what it is over the total deck, which would be 52. So 13, which is what it is, and I'll write that up here. This is on your other sheet of paper. Out of the total would be 52, and then that would reduce to 1/4. So that's the regular probability that you learned last week, and some of you struggled with it, but you didn't come to me for help, which I don't know why. I don't know, it kind of hurts my feelings. So we're going to do more with this deck of cards, but I'm going to remove it for a minute. Okay, so we're doing conditional probability. Conditional probability, the probability that an event B occurs given, and this is a really important word, that even A has already occurred. And it's denoted by this symbol here with that line through it. And here's what it is. Okay, this is how it's written, and that looks like overwhelming, but it's not that bad. So remember, you have an upside down, so we're looking for the intersection of A and B over the probability of A. So this second letter right here is always your denominator. So let me explain by doing one. So what we're doing here is, this is a deck of cards. So over to the side, just so I don't have to keep reading this, it says, so A represents aces, and there's 4 aces in a deck. So if you have your cards handy, these are your aces, and aces always mean 1 when we're doing probability. Those are your aces right there. Okay, there's 4 of them. And then it says B are black cards. Well, half the deck are black. So there's 26 cards that are black, because there's 52 in a deck of cards. And then C, that's nice, B for black, C is club. Clubs are the ones that look like, to me, they look like little puppy dog footprints. So those are your clubs. These are diamonds, hearts, and these are spades. Like if you ever do yard work, there's a shovel that kind of looks like a spade. Okay, it's called a spade. All right, so this will be easier than going back and looking at this over and over again. So when I see this, a probability of A given B, what this means is we're looking for the intersection of A intersect B. Remember, that stands for like and A and B together over, and it's always the second one, probability of B. So it's not the total cards. I'm setting a condition. I'm only giving you part of the deck to pick from. That's why it's called conditional probability. I'm not giving you all 52 cards. I'm only giving you the black cards to play with. Okay? So, and actually, watch how easy this is. Since this is my bottom one, how many black cards are there? Well, half the cards are black in the deck, so this is going to be 26. I can do that real quick. That's the easy part. So here it's, you look at these 2 letters and you go, well, how many black cards are aces, or how many aces are black? So how many aces are black? Here's my aces. 2 of them are black. That's the intersection. 2 of them are black. That's how you look at it. 2 are black out of the 26 black cards. So 2 over 26 reduces to 1 over 13. That's your answer right there. So on number 2, it's B given A. So black cards given that I'm only allowing you to play with aces. So again, the denominator is going to be just aces. That's the easy part. I already know my denominator is going to be 4. Whatever this one on the right is, that's what your denominator always is. That's the only cards that you are given. So here I'm looking for the intersection. So, sorry, you don't have to write this for your homework. So I'm looking for black intersect A. Well, I think we already did that. Given that they're aces. Well, I only have 4 aces. Well, how many black cards are aces? How many black cards are aces? That's how you read that. Well, black cards that are aces, we already found that out. It's 2 black cards are aces. So that's 2 over 4, or 1/2. So if you think about it, the probability of picking a black card that's an ace when you're only given aces is a lot better odds here, a lot better probability than over here where you're given all the black cards. So you have a better shot of getting it over here. So let's look at 3, 4, 5, and 6 real quick, all at once. If I look at just this last letter, all of these last letters here, those are all your denominators. You can do that super fast. So if I look here at C, that stands for clubs. Well, clubs are there's 13 clubs in a deck of cards. Remember, there's 13 of each kind. So I can put a 13 here right away. We'll go back and do the top in a second. Look here. How many aces are there? I'm only picking from aces. There's only 4 aces. Here again, how many clubs are there? There's only 13 clubs. How many black cards are there? Well, there's half the deck is black, so that's 26. So that's my condition. So for 3, my condition is you're only playing with clubs. You're only picking from the clubs. So then if I look at this together, I would say how many aces are clubs? How many aces are clubs? Only 1 ace is club, so that's 1 out of 13. Here on 4, how many clubs are aces? Well, here's my clubs. How many clubs are aces? Again, it's 1 out of 13, so no matter which way you write it, you're going to get the same answer. So only 1 club is an ace, so that's 1/4. Here, how many black cards are club? Well, wait a minute. How many black cards are clubs? Well, if I'm only picking from clubs, that's all the things you're giving me to play with. You're only giving me clubs, Miss Troyer. All my clubs are black. So that's 13 out of 13. That's 100%. I should bet on that. Bet Skittles. Okay, so on 26, how many clubs are black? Well, this time it's not as good because remember my spades are also black. But all my clubs are black. So that's 13 out of 26, which reduces to 1/2. Excuse me. So on the next one, which you know I'm going to love this because it's about animals. How am I doing on time? I can't tell when I'm this far away. It says we're at the SPCA, so we're going to go adopt some animals. So I got 24 dogs, 18 cats available for adoption. 16 of the dogs and 12 of the cats are female. And I need to answer a question about male, so we're going to make our own little chart. It's called a frequency table. So on this column, I'm going to have dogs and cats. You're going to have to learn how to do this, so I hope you're paying attention. And then I got females and males. And why do I have some extra columns? Because I got totals here I got to fill out. So when I go here, the first thing it said, okay, I got 24 dogs, and so I'm going to go over here to my total. I got 24 dogs, I got 18 cats, and then for females, 16 of my dogs are female, and 12 of my cats are female. And then, so how many females do I have altogether? 28. And then what's my total animals altogether for adoption? That would be 42. And then, let's see, to get to 24, 16 plus 8, so that means I have 8 male dogs. I have 6 male cats. and then males altogether is 14. And there's your frequency table. So that's going to help you answer the rest of the questions. So this is not written like it was up here, but look, there's your key word, given. Given. So the pet is male, given that it is your cat. So that means the pet is male, given that it's a kitty. So probability, I'm going to get a male given that it's a cat. So my denominator, since I'm only given kitties, how many kitties do I have? I have 18 kitties to pick from. So I'm looking for the intersection of males that are cats. And you know what? You can use your pencil. Now I don't have a pencil, so I'm going to kind of mess this up. So if you went real lightly, if you go cats that are males, you can actually see the intersection with your pen. So 6 out of 18, which reduced by 6, gives you 1/3. And there's your answer for that one. Then it says the pet is a cat given that it is female. So what's the probability that you get a cat given that it's a female? Okay, so my denominator has to be a female. So what's your total females? Well, my total females are 28. Now it has to be a kitty. So if I go cats, and it has to be female, the intersection is right there at 12. 12 out of 28. And then you simplify that by dividing by 4. So I get 3/7. So 3/7 is my probability for that conditional. And then the last one said the pet is female given that it is a dog. So the probability that it's female given that it's a dog. So my denominator is dog. So how many total dogs do I have? 24. And it's got to be a female dog, so I go dogs, female, and there's my intersection is 16. Divide them both by what? 8, I think? Yep, 2/3. And there's my answer. So that is conditional probability. And again, as usual, if you need help, you know you can find me on Meet. Okay, peace out. Hope you had a great weekend. Bye.